What's going on everyone? This is Jay Patel and this video is going to be a great one because in this video we are going to implement convolutional neural network in Keras. Now we have learned all the mathematical details behind the convolutional neural network in an entire playlist. If you haven't watched that playlist, then you can find its link by clicking at the upper I button. After all the mathematics is covered, you know what we do. We implement it in Python, and in this video we will be implementing CNN using Keras API, which runs on top of TensorFlow. And we will be making a binary image classification model where we will be predicting if the given image is a picture of a cat or a dog. And you will enjoy it very much once you implement it by yourself. And as you know, with every implementation video, I provide you with the assignment that you can complete by yourself. So in this video also, at the end, you will get the assignment where I have provided you the blanks for you to implement the entire model by yourself and check the accuracy of your model. And I think you are going to like this assignment because I remember when I first implemented such kind of program, it gave me a tremendous confidence, and it actually made me feel that I am learning something in machine learning and deep learning. And what to say, if you haven't subscribed to my channel, you should. Hit the red subscribe button, also hit the bell icon, because I upload new machine learning videos like this every week where you know the deal. I won't repeat it. So let's not wait further. Let's get right with this video. We will first start by importing our libraries. Now from Keras we will be importing models and we will be importing layers. Now when you're implementing it for the first time, you will need to install TensorFlow in your system. You can install TensorFlow from pip install TensorFlow command. I've already installed it, that's why it is showing requirement already satisfied. Alternatively, Keras is also available separately apart from TensorFlow. You can just install Keras if you do not need TensorFlow and it will work the same. And if you just install Keras, then just remove this TensorFlow and directly import from Keras. So from keras.model, we are going to import a sequential model. I will explain you what sequential model is later in this video. And we are also going to import layers of our convolutional neural network. So our convolutional neural network have conv layer, right, which is a convolutional layer. So normal conv layer is conv 2D in Keras. There's also conv 1D and conv 3D. Conv 3D is mostly used for videos, but for images we are just going to use conv 2D. Then we are going to import max pooling 2D, then dense layer. So the fully connected layers are called dense layer in Keras. And then we are going to import finally flatten, which will just flatten our multi-dimensional vector into a single dimensional vector. Apart from this, we are also going to import NumPy. So we have imported our libraries. Now it's time to load our dataset. So the dataset that I'm going to use has 1000 images of cat and 1000 images for dog in training set. And you will be able to download this dataset. I will provide the link to download the dataset down in the description box. So this is how the dataset looks like. You can download the dataset from here, and once you download this, unzip it into the folder that you are working on. Once you download the dataset, we will load the datasets. This dataset is over 1.5 GB in size, so it's going to take a while to load this dataset and also to download it. Meanwhile, as it is loading, I'm also going to write these statements to print the shape of these datasets. So the load has complete. Let's look at its shape. You can see here that this 2000 represents the total number of images that we have in our training set, and this 400 represents the total number of images that we have in our test set. Now every single image is of the size 100 cross 100 pixel and 3 for RGB channels. That's why we have this 30,000 feature here, which is 100 into 100 into 3. We will actually need to reshape these into appropriate image sizes, and we need to remove this comma nothing shape. So let's reshape these. So once we reshape this, you can see that now every image is of the size 100 into 100 into 3. Now there is one more thing here. If we print any single image data, you will see that the values range from 0 to 255, which is typical RGB values. So to train our model appropriately, we need to rescale these values between 0 to 1. So what we will do is that we will divide all these values by 255. So now if you see, the values now are ranging from 0 to 1, which are normalized values, thus our model will be trained appropriately. Now we will display our image and let's see how our images look like. To display our image, we will need to import matplotlib library, and we use plt.imshow. We will take any random image and display it. So this IDX will contain any random value from 0 to the size of the dataset. But for this we also need to import random. So this is how our dataset look like, and whenever we run this, it will randomly display the images. This is the image of cat and this is a dog. So we are done with the dataset. Now it is time to actually work on Keras and build our model. So at the beginning we imported this sequential model and these layers. So now we will be using them. So I will first tell you what this sequential model do. Sequential model means that the layers are going to be stacked up in the sequence. You know that first we have convolutional layer, then max pooling layer, then another convolutional layer, then max pooling layer, then we have a couple of fully connected layers, and that's how our convolutional neural network is made, right? So we will be stacking these layers in a sequence. So what we do is that inside this sequential, we just write our layers. So the first parameter of convolutional layer are the number of filters that we want to use. Let's say we use 32 number of filters, and next parameter is the size of the filter that we want to use. So let's say we are using 3,3 size filter. Now the number of channel part is automatically implemented. We just need to mention the height and width of the filter, which is 3,3. Then we need to mention the activation function that we want to use. We will be using relu here, and for the first layer, always in Keras, we need to mention the input shape, which means the what kind of shape is this model expecting. So our model is expecting 100, 100, 3 size images. So this is how we add our first layer. Now we will be adding our next layer, which is max pooling layer. For max pooling, we just need to mention only one parameter, which is the filter size. You can also mention the stride and so on, but if you don't mention it, it will automatically take the default value. Then again we will be using convolutional layer, and let's say again 32 filters, then 3 size filters, activation as relu. Now we don't need to mention the input shape. Input shape is only for the first layer. Now I think these are sufficient. Now we will be flattening this, and we will be using dense layers, which means fully connected layers. So let's say our first fully connected layer has 64 neurons. So this first parameter indicates the number of neurons that we want to keep in that layer. Then the second parameter is the activation function that we want to use. Again we will be using relu. Then let's say this is our final fully connected layer, which is our output layer. This output layer must have the same number of neurons as our output class, but for binary classification we only need one output neuron, and thus we will be keeping one here, and activation function that we will be using will be sigmoid because it is a binary classification. So this is how the model looks like in Keras, and we have implemented a complete convolutional neural network with just small snippet of code. Apart from this, there is another way of defining this exact same model. I will also write that model for you. In the other way, what we do is that we add layers to this sequential. Our model is defined by this sequential model, right? So we will be adding layers in this sequential model. So this is our first layer. Then we add another layer. So these two are the two different ways of defining the model. In the first way, what we do is that inside this sequential model only, we define our layers separated by comma, or the other method is we add the layers separately. The function of both these is the same. It is just the different ways of writing the same thing. You can use either of the two. So now we have built the model and it's time to add our cost function and the backpropagation. Both these are added by something called compile in Keras. So we are going to compile this model by adding the loss and the backpropagation algorithm. So the parameters that it takes is loss, optimizer, and the matrix. So here we can specify the type of loss that we want to use. As we are implementing binary classification, we will be using binary cross entropy loss. I've already talked about binary cross entropy in my previous videos. And the optimizer that we will be using is Adam. And this matrix indicates a metric on which we want to evaluate our model. So we will be using accuracy as our metric. Now there are other kind of loss functions available as well. The kind of loss function that we want to use depends on the kind of application that we are making. I will give this link down in the description box that shows all the loss functions that are available in Keras, and how to use them is also available in this article. So I will link this article down in the description box. Also, you can use different types of optimizers such as stochastic gradient descent, RMS prop, and how to use these optimizers are also explained in this article. Now here I just mentioned Adam. Alternatively, what I can do is that, for example, I can let's say I want to implement this stochastic gradient descent, then I can also write this separately and define the learning rate here. And then instead of Adam here, I just can mention OPT, which is this, and it will compile for us. This is used when we want to specify the learning rate, change the learning rate, or the other hyperparameters. But I think for this model, it's okay to go with the standard hyperparameters. So if we don't mention any hyperparameters, it will automatically take the default hyperparameters. Let's compile this model. Up till now, Keras using TensorFlow have already created the entire computational graph in the background for us. Now we just need to pass our input data and we need to fit this input data. Training of this input data is done by fit, which is model.fit. We will just pass xtrain and ytrain. Then we will pass the number of epochs for which we want to train our model, and also the batch size that we want to take. Let's say I'm taking 64. Let's fit this model. It will take a while to train this model and complete these 5 epochs. Here you can see how our loss value is decreasing and how our accuracy is increasing. So this is the accuracy of our training data set. So it has reached about 79% accuracy. We can train this for 5 more epochs and improve the accuracy. Now note one thing here, that if you don't compile this model and just fit it, what happens is that it will resume the training. So previously we saw that our accuracy was 0.79 something. Now it is 0.84. So it has resumed the training instead of starting it from the scratch. If you compile this model, then it will start the training from the beginning. Up till it is training, let's also write the code to evaluate the model's performance on the test dataset. So evaluation on the test dataset is done by .evaluate in Keras. We just need to pass the dataset here and it will evaluate the performance on the test dataset. So we have reached pretty good accuracy, which is 96.1%. Now let's check the test accuracy. We have reached 65.5% of test accuracy, which is very low, but we have a very small data set and we only have 400 examples in our test data set and we only have 2000 examples in our training data set. If we increase the size of the data set and play around with the model more, then we can improve the test accuracy as well. But for demoing the implementation of convolutional neural network, I think it is pretty accurate. What you can do is you can try a larger data set, or you can try some other data set and try to improve the accuracy in both training as well as test data set. Now we will do something cool here and we will be making predictions for the individual image. So again, we will be randomly generating an index from the test data set. Then we will display this image and we will also make the prediction for this image. To make the prediction, we need to use model.predict and pass a single example. So we have passed the exact same image, but this image has to be in shape 1, 100, 3, because our model is expecting 100 into 100 into 3 size image. Now, if you see this, this will be the probabilistic value. You can say this is the probability of an image. It is close to 0, which means that it is predicting for the class 0, which is our class dog. So what we will do is we will assign this as ypred greater than 0.5. So any value which is greater than 0.5, we will classify it as a 1. Any value which is less than 0.5, we will classify it as 0. If it is 0, it is our dog in our training data set, else it is our cat. Then we will write our model says it is, let's see what our model says. Our model says it is a dog, which is predicting right. Our model says it is a cat, which is again predicting right. You can play around with it, it's a fun game, and I hope you enjoyed this video. If you found this video helpful, then please do hit the like button, share it among your friends so that it helps me and motivates me to create more such videos. And what kind of videos would you want to see further? Let me know that down in the comment section. And do implement this model by yourself by completing the programming assignment. You will find the link down in the description box. Do implement it yourself. You can test it out with the other data sets. You can play around by changing the number of layers or the parameters in the model. So I will see you in the next video, and until then, keep writing.